So in this worksheet, limits and continuities, the very first question is saying, is the discontinuity at A in graph C removable, which is a jump discontinuity? And the answer is no, it is not removable, because even if the hole, so you can see on this graph, even if this hole at A was filled in, it still does not connect. There's still an empty space, and our graph will not connect. Whereas with a removable discontinuity, something like this, where the hole isn't filled in, if you filled it in, the graph still connects. And then our second question is the discontinuity at A in graph D removable? And then explain why. So we have an asymptote discontinuity, infinite discontinuity, where the graph of the line is slowly but never actually reaches A, which means that no matter, even if A equaled X, and there wasn't an asymptote there, that there's no possible Y value you could put in. There's no value on the y-axis here that we could put in to get those two graphs to connect, which means it is not removable. For the next question, it says classify the discontinuity in the following functions as the given values. So that means I put in 0 into our g of x right here, and the answer I got was -4. But I did, if you go through the math, you see that I had to cancel the x's. So that means that the discontinuity here at x equals 0 is a whole, because when you cancel the x on the numerator and cancel the x on the denominator, that means you've removed a part of the graph where it cannot, the limit does not exist. This next question is asking what the discontinuities are at x equals 0 and x equals 1. So what you do is you take your 0, plug it into your g of x. As you can see here, I plugged in 0, and I got -4. But if I plugged it in just regularly without factoring, I would have gotten a 0 on the denominator, which is not allowed. So I factored it out, got x over x, and canceled that, which means that the discontinuity at x equals 0 is a whole, because when you cancel something on the numerator and cancel it with something on the denominator, that means that you've removed it from the equation, and there is now a whole. The next one is asking at x equals 1. So when I plugged in 1 into my equation, I already had the x's canceled from the top one that I did, which got me 1 over 0. And that means it is an infinite discontinuity, because there is an asymptote, because 1 over 0 means that it is undefined at x equals 1. So x equals 1 is our asymptote, and we have two graphs approaching it slowly but never actually reaching it. In this next question, we are looking at this graph right here, and we're finding all of the discontinuities. So the first one you can see is at 1, x equals 1, because this point right here is not filled in, which means that it is a whole, because f is not defined and a is not in the domain of f of x. The second discontinuity we can see right here is an asymptote, because this line right here is slowly approaching but never actually reaches our line at x equals 3, which again, asymptote, because limit of x approaching a of f of x does not exist. Then we have the third one, which you can see right here, because these two graphs do not connect. We also have this not filled in hole. You know that it is a jump discontinuity at x equals 4, because the limit of f of x does not equal f of a. Here we're looking at this piecewise function and seeing whether or not these statements are true or false. So we have f of x when x equals -3 is defined, and that is true because x equals -3. Our answer, f of x equals 4. And that means it's a defined point on our graph. And then we have limit as x approaches -3 of f of x exists. And so we can see that approaching x from the negative side, we have square root x plus 52. In this situation right here, we see that limit of x approaches -3 of f of x, we know that that actually equals 7 after we plugged that number into x, and then we know that when f of x, this last question here is really going off of this question C is asking if it's continuous, if f of x is continuous at x equals -3, but we know it's not because in this case right here, we're plugging in and lastly, we have question D, which is actually going off of question C, and it's asking if f of x is continuous at x equals -3, and we know it is not because you already know that one side of x equals -3, you get your answer is 7, and the other is 4, so we know that it is false. It is not a continuous line, otherwise those points would equal the same.